Hello students, Jai Swaminarayan. I am Professor Urvish Mewada, HOD Electrical Department, Sri Swaminarayan Institute of Technology, Bhat Gandhinagar. I am the subject matter of Industrial Instrumentation subject, which is in the 7th semester Electrical Engineering, and GTU subject code of this subject is 2170913. Students, we are currently discussing the chapter number 6, that is flow measurement, and in which today we are having lecture number 3, and in lecture number 3 we are going to discuss the topic number 6. So before we discuss this topic, just recall, just here we are recalling the previous lecture number 2. So in lecture number 2 we have discussed the third topic for the flow meter, and in which we have discussed the venturi tube in detail, say construction and working of the venturi tube, and then after we have discussed the advantages of venturi tube with its say animation of the venturi tube, and then after we have discussed the limitations of the venturi tube. Also in topic number 4 of the previous lecture we have discussed the orifice plate, and in which we have discussed that orifice plate in detail with its principal construction and working, and the different types of shapes of the orifice plate generally we use for the measurement for commercial, residential, and say industrial or agricultural purpose. And in which we have in lecture number 2, the topic number 5, that we have discussed the pitot tube, in which we have discussed the say working principle of the pitot tube, then the construction and the working that we have discussed with say animation or GIF of the pitot tube. So this is on the topic number 6 in the unit number 6. The lecture number 3 is the topic number 6 is rotameter. So this is again a device which we can use for the measurement of the flow. So let us discuss how this rotameter work. So in rotameter basically, say this is the we can say the shape of the say rotameter. Over here you can see that, and in this rotameter you can see that basically the device is used to measure the flow rate of a fluid. So generally for the measurement of the flow rate we can use this rotameter, and the placement of the rotameter say basically it is in the say vertical tapered tube. So over here you can see that the shape of the this rotameter is at the bottom side it is narrow, and the upward side it is wide compared to the bottom side. So that's why it is called the taper, and it is tapered tube with a float. So in which this is the portion, or we can say the element that will float whenever the fluid which is passing through this pipe, and which is free to move within the tube. So whenever the fluid acts act inside this pipe, and according to the fluid flow or pressure, this float will say allow to fluid means it will get float, and it will allow to transfer the fluid through this pipe, and the fluid which enters say the device from the bottom over here, and the flow upward. So this is the outlet head. So over here we will get the outlet of the fluid, and when there is no flow, so the float rests at the bottom. So this float is having a certain weight, and due to the gravitational pull, if there is no flow, then this float will set on the bottom, and there is say it will not indicate any of the reading of the flow, because we are not transferring the flow through it. And the flow has the say density say higher than that of the fluid flowing the fluid. So yes, if the density is lower than the fluid flow, then it will not indicate the any reading, and it will say easily allow to the allow fluid to transfer through it. And the float is say made of such diameter that is completely block the inlet. So over here you can see that this is the float. Whenever the fluid transferring through this, so this float will go upward, and whenever this float is at bottom side, it doesn't allow any means fluid to transfer through it. So whenever the say flow rate, or we can say density of the fluid is become greater than the density of the fluid, then this fluid will allow to fluid through transfer through this tapered pipe. And according to the density of the fluid, this fluid will set a level, and on the say the glass tube, we have the say scale, and whenever a point where the fluid remains steady is the actual flow rate through this pipe, indicated by this rotameter. So this is the animation which is showing that over here. From this you can see that flow is transferring and this fluid is going upward, and it is allowing flow through it, fluid flow through it. And this is the diagram that you have to draw in the exam whenever such kind of theory is asked in your exam. And this is the animation which is showing the working function of the rotameter. So let us discuss the working function in detail, means theoretical working function. When the float starts, the buoyant effect. Buoyant effect is effect of the say when the float will go upward because of the fluid pressure. And say that fluid make the float lighter, and but it is but it is insufficient to lift the float. So when the fluid pressure exceed the downward pressure due to the weight of the float, so the float rises the floating. So this is what I have explained in the previous case. So whenever the density of the fluid, or we can say flow rate, will be more compared to the floater which is floating inside the tube, then this floater will allow the flow to transfer through the pipe. And for every float position there is a definite flow rate. So yes, according to the flow rate, this float will set a position, and that set position is say all we have already say on scale on the surface of the float, means rotameter. And a point where the floater will set a level, it is the actual flow rate through this pipe. And the float which rotates when the liquid passes, and just keep the float in say equilibrium. So yes, it is most necessary point. If the fluid pass through this, and if the pressure is uneven, or we can say pressure is turbulent, it will turbulent, but that will rotate the floater, and that rotation make it balance inside the tube while the flow transferring through the pipe. And whenever the flow rate decrease, or we can say there is no flow rate, it will set its original position with the same shape or on the initial position. So yes, this is the most important point. And the large tube of the magnetic coupling is say used to indicate the fluid position. So let us discuss the application of this rotameter. So it is suitable for low viscosity fluids. So if the viscosity of the fluid is more, then this floater will not show the exit reading. And for measuring flow rate of say machine coolant, lubricating oil, and light slurry, etc., we can measure the flow rate of such liquids, such fluids. And let us discuss the advantages of this rotameter. So the fluid position can be seen, and the range can be changed by changing the tube and float. So yes, by changing the tube size and the floater weight, the floater which is floating inside the tube, we can increase or decrease the weight according to the requirement, according our requirement for the fluid flow measurement. And it is having a good accuracy for low flow rate, and say it is having say remote indication also possible. So these are the advantages, make it feasible to use for the industrial as well as the residential and commercial purpose for the fluid measurement. Now let us discuss the disadvantage of the rotameter. So rotameter is having glass tube, it is fragile. So yes, after certain use, we can say it will not show a proper say opacity. So yes, whenever the liquid is having slurry or any contamination present, then due to the abrasion, or we can say friction between the particles and the tube, the visibility will become poor of the rotameter, and the less accurate say compared to the venturi meter and the orifice meter. So yes, In feasibility, venturi tube and orifice meter is more feasible compared to the rotameter, and it can be installed in vertical pipeline only. So whenever we have a horizontal flow measurement, then we cannot use this rotameter for the flow measurement. So this is the biggest limitation of this rotameter. And the float cannot be cannot be seen if the fluid is say dense. So yes, if the fluid is having contamination, or we can say the fluid is not transparent, then we cannot see the float. And it is not suitable for say pulsating flow, and also for high pressure and the temperature fluid. So yes, this are the disadvantages of this rotameter. So this is how we can explain the rotameter for the fluid flow rate measurement. So now let us discuss the next topic number 7, that is turbine flow meter of this unit number 6 and lecture number 3. So yes, turbine flow meter, let us discuss how turbine flow meter works actually. Yes, as per the name turbine, it is say mechanical device, and this meter generally translate the mechanical action of the turbine, which is rotating inside the liquid, or we can say in the flow around an axis, into say user readable flow. So whenever the flow crosses to through this pipe, this turbine will rotate. And yes, turbine flow meter is mainly used for the say purpose of say measurement of liquid and gas at very low flow rates. And therefore the flowing fluid inspiring say on the turbine balance, or we can say imparting a force which allows this turbine to rotate, and which tugs on the blade and force on and setting the rotor in motion. So yes, whenever the fluid we can say imparted on the struck on the floor, we can say the blades of the turbine, then yes, it is having a volute shape. So whenever the fluid struck on this blade of the turbine, then this turbine will get rotated due to the fluid flow rate. And the rotor will go into the motion. And when the steady rotation is reached, the speed is proportional to the fluid velocity. So whenever we get the steady rotation according to the fluid flow rate, so that will indicate the speed which that is indicated by the speed which is in proportional to the fluid velocity. So yes, let us discuss with the first diagram, in which you can see that this is the magnetic blade or tip, which is means having a magnetic contact. This is the flow which is transferring through this is the inlet side, and this is the portion which is outlet side. And this is the rotor blade, means both are the rotor blade, to which we have connected the means we both are connected with the magnetic blade tip. And this is the point where the magnetic pickup coil is connected on the surface of the tube. And yes, whenever the magnet which is connected on this means blade of the turbine reaches in front of the magnetic pickup coil, it will produce an electrical output in terms of the flow rate. So yes, this is the cross section of this turbine flow meter. So in turbine flow meter, you can see that this is the point where we have connected our magnet, and this is the pickup coil which pick up the signal of the rotation while the magnet will reaches in front of the pickup coil. And this is the say diagram which is indicating again a cross section, which is indicating that this is the point where we are inserting the flow. And this is the say axle of the means turbine flow wheel. And this is the rim on which means on the surface of the blades. And this is the magnet which is connected with this rotor. And this is the outlet flow, and this is the coil which is connected on the say surface of the pipe. And the connection say to the data logger. So to these two wires are going to the data logger, which actually means note down all this means all the contingency, or we can say all the working of the say turbine flow meter, or that will note it down all the say parameters which are related to the flow rate of this turbine flow meter. And here whenever the fluid which is transferring through this pipe, this turbine will get rotate. Therefore the volumetric flow rate is say linear within the given limits of the flow rate, and the output is in the form of they say pulses. So over here you can see that the pulses are generated in this animation, and which can be obtained the magnetic pickup coil, and the pulses frequency varies, the pulse frequency varies linearly. So over here you can see that, and the volumetric flow rate over the specified flow range is also you can see that, which is transferring through this turbine flow meter. So over here you can see that whenever we are having the flow rate inside this pipe, this turbine will get rotate, and the magnet which is connected with this turbine flow means turbine blade, so it will go in front of the turbine flow meter, and this turbine flow meter will produce the pulses according to the rotation of the blade. Now let us discuss the construction. It consists of the say multi-bladed rotor, which is same mounted at the right angle. Yes, we need to mount it at right angle, because we will get the exact flow rate by the more contact means contact surface, or we can say contact of the on the blade of the water, and the angle to the axis of the flowing fluid. Yes, both are at the 90 degree to each other, and the rotor is supported by the shaft, and the say rotates freely about the axis. Basically, yes, this is the say mechanical arrangement. So it is having a free flow motion. If we struck anything which can rotate the rotor easily, then that rotor will get rotate whatever the impart on the turbine blade of the turbine flow meter. And when the flowing fluid say impinges on the blades of the turbine or rotor, it imparts a force, and so that the rotor will get rotate, and rotor speed is proportional to the fluid velocity. So as fluid velocity increases, rotor speed will also get increased, and it is basically depending on upon the volumetric flow rate. So whatever the volume transfer through the pipe, according to the transferring of the liquid, the turbine flow blade will get rotated, and it will give the output according to the flow rate through the pipe. And as rotor blade say passes the magnetic pickup coil, the magnet which is connected on the surface of the rotor blade, it generates a voltage pulse, and say total number of pulses given give a measure of on the flow rate. So yes, according to the say here we are using the magnet, and on the upside means on the surface we are having the magnetic pickup coil. So yes, due to the cutting action of the magnetic lines of force, the coil will produce an EMF, and that EMF is nothing but the flow rate through that pipe in terms of electrical output of the physical quantity flow rate. Now say induction pickup coil type turbine flow meter. Over here you can see that this is the turbine, and in the previous case we are having a turbine is made up of cast iron or any other type of material. Over here we are having a turbine which is made up of say permanent magnet. So yes, you can see that whenever this point will reaches in front of the say magnetic pickup coil, then magnetic pickup coil will produce the electrical output. Basically this electrical output is in sinusoidal in shape. So yes, generally permanent magnets are embedded on this rotor, so that's why this permanent magnet, whenever this permanent magnet go in front of this coil will produce an electrical output. And the operating temperature say for standard pickup coil is -50 to 150 degrees centigrade, and higher temperature say modified pickup coils are say incorporated. So yes, in say hazardous area, coils are mounted in a flame proof or say explosion proof boxes. So yes, that can prevent this device as well as the human which are surrounded to this inductance pickup coil type turbine flow meter. And also the output is continuous sine wave voltage pulse which represent volume of the fluid. And as the magnet rotates past the pickup coil position, it generates a voltage pulse for every complete revolution of the rotor. So yes, according to the revolution of the rotor, this rotor will cut the magnetic flux. I mean, this rotor is having magnetic flux, and this conductor will cut the magnetic flux, and it will produce an electrical output of the physical quantity flow rate. Now let us discuss the application of this turbine flow meter. The application is, it is used for the liquid and gaseous for very low flow rates and say insertion gauges. Also the advantages of this turbine flow meter is, say, it is most accurate for say low to medium viscosity fluid. Yes, that this is most important. If the liquid viscosity is more, then that will means the blade will create more resistance to the fluid, and the flow rate means we can cut the flow rate means resist the flow rate due to cut the flow rate due to the resisting of the resistance of the blade. So yes, it is having a good reliability, and it is suitable for say limited pressure and say extreme high and low pressure. And it is easy to install because it is having a small structure, and the small in size and weight. So yes, this design make it compact, and it can be made say hygienic. So we need to keep in mind it can be made hygienic for the advantage, to take the advantages of this turbine flow meter. Now let us discuss the disadvantage of this system. So it is not suitable for high viscosity or dirty fluid. So yes, that will be resist by the turbine blade shape, according to the turbine shape of the turbine blade. And possibility of say damage due to overspeeding during liquid gas. So yes, if we want to measure a pressure, or we can say flow rate, then we need to keep it steady or stable while we are using it. And the third is it requires a secondary readout. So these are the point that we can discuss in the turbine flow meter. Now let us discuss the topic number 8, that is electromagnetic flow meter. In electromagnetic flow meter, as per the name, the flow rate is converted into the electrical output. So let us discuss how this electromagnetic flow meter works. In this you can see that, so the first advantage of this electromagnetic flow meter is it can be used for measuring the flow rate of heavy suspension liquids such as slurry. Yes, for the industrial purpose we have certain type of liquids in which we have say slurry or mud or sewage, or we can say wood pulp. So as no absorption of say obstruction to the flow. In previous case, whatever the flow meter we have studied, in which we all have the obstructions. So after obstruction we can measure the flow rate. So yes, this liquid having say there is no obstruction of this in the flow through the pipe, and the pressure head loss is almost negligible because we do not have any obstruction, so there is no loss of the pressure head. And the upstream flow say disturbance do not affected. So upstream as well as downstream, both will not get affected the performance of the electromagnetic flow meter. Also this flow meter can be used as say bidirectional meter. Yes, in the previous all the flow meter that we have studied, so we need to change the direction or whenever the flow direction changes. But in this case it is a bidirectional meter which can measure an electrical output which which is having say change in the flow rate. Now means flow direction. And now the next advantage is that it is having extremely low flow. Means extremely low flow can be much handled by this electromagnetic flow meter. So this is the biggest advantage, make it feasible for the industrial purpose for the measurement of the flow rate. Now the application of the electromagnetic flow meter. So let us discuss the application. So yes, this is the most important point that we need to keep in mind. This matter is used for say fluid is having say electrical conductivity above 10 micro per Siemens per centimeter. So we need to keep in mind we can use the conducting liquid of this level for the measurement for the flow measurement using the electromagnetic flow meter. So the first means the application is that it can be used for the sand or slurry flow measurement. Or this are the basically various fluids whose flow can be measured using electromagnetic flow meter. So the first one is sand and slurry, and the second one is say process slurry. So this slurry is a word related to the contamination which are present inside the liquid, or this such kind of liquids are generally used for the cutting, or we can say polishing or scrubbing of the materials in the industry. And the third one is sewage, fourth one is wood pulp, fifth one is hot fluids, and the fourth one is say water, or say other than the distilled water. And the sixth point is say viscous fluid such as food processing unit, and the seventh one is cryogenic fluid, etc. So yes, these are the material, or we can say fluids, the flow we can measure using the electromagnetic flow meter. And this electromagnetic flow meter theory is one of the most MP theory of this chapter. This theory is a theory which is frequently asked in the GTU exam, or we can say repeatedly asked in the GTU exam. So please go through it carefully. And yes, after this presentation you are having the assignment question, these are the assignment question. This is the printing mistake. That assignment question is say explain a ROTA meter for flow measurement, and the second one is explain electromagnetic flow meter in detail. The instructions which are related to this assignment question are written below. Please read it carefully and do it accordingly for the submission of your assignment. And if you have any query or any doubt related to this topic, then we can solve your queries or doubt in our doubt solving session. And if any further query arise after going through this presentation, then feel free to call me to solve your doubts related to this topic. As well as if you have any doubt while you are reading any topic of the electrical engineering, then feel free to call me to solve your doubts of the electrical engineering. So this is what I am done for this time in this presentation. Thank you very much, student. Thank you very much all. Jai Swami Narayana.